Alright, it's time for the upper level problems in this section. Now we're going to look at this from two different ways to do it. Right, so we have one way that's more log-ish, we have one way that's more exponent style. So the first way I'm going to look at is from a log standpoint. So I can't change the base. The converting to log method won't really work here. So my best option here is to start off by giving it a log. Log of 6 to the x minus 1 equals log of 8 to 2 minus x. Exponents come in front. X minus 1 log 6 equals 2 minus x log 8. Now our biggest issue here is that we're solving for x, but we have x on both sides. We have x on both sides, and we have to set this up so we only have one individual x. So it's kind of strange, kind of different, but we actually have to work backwards in this situation. Usually we want to kind of simplify things so that we have one log equals one log. We want to go the other way. We want to expand this out. So I can actually distribute my log 6 and make this x log 6 minus 1 log 6 equals 2 log 8. Got sloppy there. 2 log 8 minus x log 8. By doing this, we can now reorganize things so that we can have it where all the x's are on one side. So if I add over the x log 8 and I add over the 1 log 6, which I'm just going to write as log 6, I've now set this up so I only have one log, x on one side. Right? And we could keep taking this further. Right? So I only want to have one x to solve for. So I could use a factoring rule of GCF. By GCFing, I have x log 6 plus log 8. Right? And know what? I could simplify inside using the addition log rule to make this x log 6 times 8 is 48. And if I want to, on the other side, I could kind of go the same direction. I could bring up my exponent, make it log 64, plus log 6, which if I combine those, is log 384. Divide by log 48. And x equals 1.537. So that's one way to attack this problem. Again, if you like that method, stick with it. Nothing wrong with that method. The second idea I have here is that we can use the exponent rules. So if I know I have exponents and I see subtraction up there, subtraction means that I was dividing at some point. So what I really have here is 6 to the x over 6 to the first equals 8 squared over 8 to the x. Right? Because the idea is that division means subtraction. Right? So I could take a moment right now and I can reorganize this. I got 6 to the x times 8 to the x equals 6 to the first times 8 squared. Right, so if I have 64 times 6, I have 384 over here. Right? I can combine this into 48 to the x. Right, now I'm starting to get those similar numbers we had before. Right, so since I have 48 to the x equals 384, I could convert, or I could go give it a log. Well, I'm going to convert. Log base 48 of 384 equals x. Log of 384 divided by log 48 equals x. X equals the exact same thing as before. Right, so either method works. It's just basically go with whatever you're more comfortable with. Right, so if I look at this next example, right, opinions, what am I going to go with? I'm going to go with the exponent form. 7 over to the x over 7 squared equals 5 to the third over 5 to the x. Now, being honest, not every time, is this method the best? You could do whichever method you want. Sometimes one option is better than the other depending on what's going on. So for this problem, cross multiply. 7 to the x times 5 to the x, 7 squared times 5 to the third. This becomes 35 to the x. 7 squared times 5 to the third. That becomes 6,125. Convert the log form. Log 35 of 6,125x. X equals, let's see, log 6125 divided by log 35, 2.453. That's with the exponent rule. If I go back to the log rule, right, this problem will also work. So here I'd have x minus 2 log 7 equals 3 minus x log 5. Expand. All right, so now I got it all expanded. X is to one side, numbers to the other. X log 7 plus x log 5 equals 3 log 5 plus 2 log 7 GCF the x. Right, so I can combine this out if I want. I can leave it exactly the way it is. So if I want, I can make it log of 125 plus log of 49 x log of 35 equals log of 6,125 divide by log 35 divide by log 35, and what do I get? The exact same answer. Doesn't matter which way we do it, whatever works best for you is fine with me.